Hey, friends, I hope that you all are having a wonderful day. You all are going to be with Miss Floyd today, and we are going to be talking about Earth's patterns, Earth's features, tectonic plates, and volcanoes and earthquakes today. I know that you all have been talking a lot about topographic maps and mountain ranges with Miss Albrecht and Miss Pergram, and now we're going to take what we've learned over the past couple of days and apply it to earthquakes and volcanoes. So we are going to do some mystery science today, and I will let Doug take it away.
This is lava. Wow, so awesome. This stuff is so hot. Anything flammable that lava touches, check it out, instantly catches fire. Or see these tree roots burning as lava touches them? Lava is so amazing. Think about what it is. It's a liquid. You can see here, it's flowing. But it's rock. It's liquid rock. In order for rock to melt into a liquid, it has to be really hot, nearly 3,000 degrees Fahrenheit. Now, lava, as you know, flows out of a volcano. Most of us don't live anywhere near a volcano. So it would be so awesome. It would be the trip of a lifetime to get to go near one and be able to see lava up close like this. But what if you didn't have to visit a volcano? What if a volcano came to you? Like, what if a volcano erupted in your neighborhood? That's just crazy. Could a volcano ever pop up in a place like a backyard or a park? I know what you're thinking. No way. But let me tell you a true story about a man who lived in Mexico in a small town called Coutine. One day, February 20th, 1943, this guy, a man named Dionisio Polito, was out in his fields with his horses, plowing the earth so that he could plant corn. But at 4 p.m. that day, there was a tremendous boom. The earth shook. What happened? Dionisio went to look around, and he found a large crack in his field, just like this one. Before long, lava began to squirt out of the crack. And by the end of the first day, there was no longer just a crack. Now, the lava that cooled had started to form a hill about 160 feet high. This is a real photograph of that volcano in Coutine during its first few days. The townspeople gathered around to watch it erupt. How incredible, they thought, to see a tiny volcano forming in what was just yesterday a flat cornfield. The volcano kept erupting lava every day. After about 3 months' time, lava was now starting to flow closer to the main part of town. Everyone immediately left town to seek safety elsewhere. But as they turned back to look, that's when they realized there'd be no coming home. This wasn't like a flood, which eventually flows away. It was lava. And what does lava do when it cools? It hardens to rock. This is the town of Coutine today. You can see that the town was buried. It was frozen in rock. All of this rubble here is the hardened lava rock, a type of rock which scientists call basalt. When the lava came through town, the intense heat burned down all the wooden buildings. So today, only a few stone buildings, like this church, are left. That's the top of the church, poking through the basalt. So I ask you again, could a volcano ever pop up where you live? Maybe you say, no way. But it happened to Dionisio Polito. Are you sure it couldn't happen to you?
All right, take a minute, pause the video, and write this in your journal. Do you think that it is possible for a volcano to pop up where we live, Lexington, Kentucky, in the middle of the United States? Do you think it's possible? Why or why not? Pause the video right here and jot some ideas in your science notebook. All right, now that you have all of your ideas written down, let's go on.
Now, there's something else I should tell you about the area where Dionisio Polito lived. Earlier in history, people had recorded other volcanoes that had erupted in Mexico, like here and here and here and over here. These volcanoes are all pretty close together. They almost form a line. I'll call this a pattern, since it's like you could connect the dots. Now, as of right now, you don't know why volcanoes are found here, but with our pattern, it's like we could predict where another volcano might form. Like, look at this gap here. This spot is right in the middle of the pattern, between two other volcanoes. So it's not crazy to expect another volcano to form here. Sure enough, that's where Dionisio's town of Coutine is located. A volcano formed there in his cornfield, which seemed kind of shocking, but when you look at the bigger picture, it really makes sense. It's part of a pattern. So, could a volcano erupt where you live? Well, surely all of the world's volcanoes aren't just over here in Mexico. But where are the other volcanoes? Suppose we had a list of all the volcanoes of the world and we mark them on this map. Do you think maybe we'd see an even bigger pattern?
All right, before we go on, think about it. Do you think that if we plotted all of the volcanoes in the world, if we would see a distinct pattern? Do you think they're sporadic, or do you think they're located in specific locations on the Earth's surface? Well, usually we do this activity in class, but for time purposes, we are going to skip ahead, okay? So we do have all of the list of volcanoes. And I am going to skip this and we are going to look at how those volcanoes are plotted on the map after the activity. All right, friends, if we were to plot every volcano on the Earth, it would take a very long time. So, this activity only focused on a handful of volcanoes. And as you can see on the screen, they have been plotted for us. Do you notice a pattern? Are they all over? Or are they in a distinct pattern? Let's learn about that.
When you brought your maps together, you saw something like this. Maybe you noticed that you could kind of connect the dots between the volcanoes. This pattern, this line of volcanoes around the Pacific Ocean, this is one of the Earth's major features. Scientists have a special name for it. It's called the Ring of Fire. We call it this because it forms a kind of circle of volcanoes around the edge of the Pacific Ocean. It resembles a ring, or you might say it's more of a horseshoe shape, but horseshoe of fire just doesn't sound as great. Now, we didn't have your class put every single volcano on Earth on the maps, because that would have taken hours. But even when you add the rest of the volcanoes on the map, like this, do you see how the Ring of Fire pattern still stands out? 75% of the world's volcanoes occur in the Ring of Fire. Why? Why do so many volcanoes occur in this ring? Well, there are scientists who travel to volcanoes to figure out answers to questions like this. They're called volcanologists. They have some ideas, which you'll learn more about in the future. One important thing to notice is that volcanoes always occur in clusters or groups. There hasn't ever been a case of a volcano just popping up in the middle of nowhere on its own. There's always a group of them. Even the volcanoes that are outside the Ring of Fire are in groups, like these volcanoes here that form Hawaii. So could a volcano pop up in your backyard? You have some ideas now. It seems like it's going to depend entirely where you live. If you don't live along one of these patterns of where volcanoes are found, like the Ring of Fire, it seems like the chances are probably a volcano is not going to erupt in your backyard. But if you do live along the Ring of Fire, it's not out of the question. It happened to Dionisio Polito in Mexico, and it's happening right now in other places. Let's zoom into the United States. Notice that in Southern California, right here, there aren't any volcanoes, but there are lots of volcanoes north of there and south of there. So could one pop up in Southern California? Well, let me show you something interesting. Even though there aren't any volcanoes in Southern California, there is this. It's about 2 hours from Los Angeles, near the Salton Sea. It's boiling mud and steam rising out of the earth. Mud doesn't normally boil, so scientists believe that there's lava that's under the surface, causing things to heat up. So far, nothing has happened, but a volcano could erupt in Southern California one day, just like in the cornfield of Coutine, Mexico. Could it happen to you too? Are there any volcanoes close to where you live? Have a look at this map and discuss.
So let's look at this. We live in Lexington, Kentucky, not in the middle of the United States, but it's right around here. Put in your science journal, do you think that a volcano could pop up in the parking lot of Stonewall, or in your neighborhood, or in the middle of the football field at UK? Think about what we learned. Could it happen? Pause just for a second and discuss that. If you said no, you are probably right, because we know that volcanoes do not just pop up on their own. They form in groups. Do we have any other volcanoes around our area? No. So probably that would not happen. All right, friends. So now that we've learned about the Ring of Fire, what it is, what happens, I want you all to now go watch the Brain Pop video and learn about why volcanoes happen at the Ring of Fire. On your exit slip today, I want you to use the information you have learned on both videos to answer your exit slip question of, why are there so many volcanoes on the Ring of Fire? Why do we see this pattern as Earth's feature? But you have to use the vocabulary word tectonic plates in your answer. All right, guys, good luck.